It was showing hot night, wind was blowing. Where you think you're going, baby? I just make it hard to look back. Won't you
Take a minute.
Yeah. No. You made it the hour walk. Long. That's basically. Yeah. She's gonna get a new phone courtesy of my.
Good question. Gone.
I was a bit confused. I tried my best, but I was a bit not sure on 27 because I thought that if it was like multiplying by 1 or adding 0, it didn't count.
The same thing.
Oh, it didn't count?
That's what I thought. Is that wrong? Okay. Thank you. That's what it's here.
Sure.
Are we gonna get our quiz back today?
No, not today.
Mr. Lieberman, can I take it during summer period tomorrow? The quiz?
Is that the earliest now?
Yeah.
Fine.
Okay, sorry.
Never.
Probably really high.
It's extremely hot. Yeah, it's the only short chapter of the book.
What book are you reading?
Any other test corrections?
I think I have, but like 7 years. I have some.
Check 1, 2, check 1, 2. So close. So close.
Yeah, look at, I think there was one go, like. Yeah. So.
Crazy.
Oh, yeah.
Almost done. But isn't that, isn't 12?
They're
We're starting at 12. Quick. 12:15.
We don't need them.
Yeah, please, if you have your test corrections, come on and bring them up. Seems so ancient history now. Right there. There you go. Thank you. Good afternoon.
We do.
Who slept past 8 today? Besides curiosity. You take advantage of these days? A little bit late? Hope so. If you didn't, I hope you have a good reason. Maybe you'd like to get up early, which is great. I know you did bog down with work, so it's at least nice to do a little bit of work in the morning, isn't it? To have that extra time. So you don't have to stay up late. Okay, so I heard you were very good from Mr. Sim. Thank you. Was he good? He treat you right? Okay, good. Let's get right to it. We're moving on to systems not of linear equations, but systems of nonlinear equations. Up to this point, really, you've just talked about when two lines intersect. But how about when a circle intersects a parabola? Or a line intercepts a hyperbola? These are things that could happen. We're gonna look at some of this today. What two structures are we dealing with here in number 16? We check with your neighbor, what are the two structures here? AJ, who's missing? No,
Grace.
Okay.
Maybe she's late.
No, she has a meet today.
Wait, I mean, you did.
No, never alone.
I know.
That's right. I have you moved.
Oh, actually, very smart.
You want to get a chance Okay, so the first shape is, of course,
Ellipse.
an ellipse, and the second shape is a line. Do you think it would be helpful to graph these? It might help, but it seems kind of like a pain, doesn't it?
Yeah.
So how many solutions are possible if we have an ellipse and a line intersect?
Two.
Is it exactly two? Always two? It could be one, can't it?
Mhm.
What would it look like if it's one? The line would be tangent to that ellipse, right?
Or can be no solution.
Or it could be no solution. So let's let algebra do the work rather than struggle through drawing it. Although you could complete some squares and divide through by whatever it equals, because we know it has to equal one in standard position or standard form. Okay, but how are we going to do this?
Substitution.
Yeah. Josh, you have an idea?
Substitution, find out what x equals in terms of y, or what the x and the x values.
Yes, yeah, we already have y here and here, so let's turn the x's into y's. Yes, Kate. You could set them equal to each other, but then you have a big long equation with x and y, which is not helpful because we want a single variable. But you're right, that would not be incorrect, just I'm not sure how helpful it would be. Okay, so from here we know that x is equal to 3y plus 3, is that right? I'll give you a minute to solve this. Elimination, not helpful for these. Always. Not always helpful, I should say. Thank you, neighbor. Make sure everything's going well here.
I just.
Get it? Are there two solutions?
Yeah.
Can I ask Destiny to help us here? See the Lady Destiny. Show us their algebra prowess. Siona, can you help us with this, please?
So I replaced the x squared with 3y plus 3 squared. And
Okay.
so then when I multiplied that out, I got 27y squared plus 54y plus 27.
Here, let me write this down. Maybe I'll do this, this 9y squared plus. It was 18y plus 9, is that right? Plus 2y squared minus 54y. Does this match what you did?
Yeah.
Okay, then you multiply that out to get,
Yeah, so then I got 27y squared plus 54y plus 27. So the 54y is canceled. And I got 29y squared minus 116 equals 0.
29y
Then-
squared. Okay,
Minus 116 because I combined the 27 and negative 1.3.
okay,
Then I moved over the 116, divided it by 29, and I got that y squared equals 4, or y equals minus 2.
so you're saying that 116 divided by 29, it goes in well? Goes in nicely?
It went
This,
4 times, so y squared equals this, so y equals,
plus or minus 2.
nice,
Then I picked the second equation, that's much simpler,
okay,
and I plugged in positive 2, and I got that x equals 9. And then I plugged in negative 2, and I got that x equals negative 3. So the 2 points would be 2 comma 9, and negative 2 comma negative 3.
let's make sure to keep them in order,
Uh-oh. I think,
so -3, right?
yeah,
So you said when you plugged in a y equals 2, you got x equals 9?
yeah.
Okay, so the ordered pair would be what comma what?
Oh, 9 comma 2.
9, 2.
Yeah,
The other
9
one is,
and negative 3.
does that process make sense and follow basically what you did? Cool, nicely done, thank you. Do you know what the graph of xy equals 6 looks like? Perhaps you'd be more familiar with it if you saw it for y equals
6 and 1.
6 over x. We've discussed with your neighbor what this looks like. Can you show me what it looks like? Which quadrants? 1 and 3, it kind of looks like this and this. Do you know what a shape that is? Do you know what kind of a shape that is? It's actually a hyperbola. A slanted hyperbola, right? So it has the asymptotes. Probably the first hyperbola you ever did, maybe algebra 1, algebra 2, definitely the beginning of this year with the 1 over x. But yeah, so it's that. Not that it's necessary to do this problem, but kind of cool. The other equation is of course a line. So it could have it could have up to 2 different points of intersection. I'll give you a minute to figure that out. And work through this problem, figure out the points of intersection, if there are any. Calling on someone pretty soon. So check in with neighbor, make sure they got it. Cyrus, can you help us out with this, please?
So you plug in, 6 minus x for y. And then,
6 over x.
or 6 over x for y. Equals 1, and then, I combine them by doing 2x squared. Minus 6 over x equals 1, and then I subtracted 1 from both sides.
Okay,
Or actually, you can multiply by x, right?
you can. Should we do that?
X and then subtract x, then 2x squared minus x minus 6 equals 0. And then to factor that, it should be 2x minus 2, or and times x plus
There's
3.
an X there. Let's see, is it 2 and 3? Would that work?
I think it's +3 and -2.
It's 3 and 2. I commit to the signs and just kind of plug in numbers this way. So is this going to work with the 3 and the 2 here?
Yeah.
Check the inners and outers. We have 4x and 3x minus plus. So we get x equals -3/2 and 2. Sorry, so okay, continue.
And then you can plug or test both of them in the first equation I asked. So then -3/2 y equals 6.
Okay.
And then y would equal -4.
Okay.
And then 2y equals 6, y equals 3.
So solutions.
-3 comma, or -3/2 comma, -4 and 2 comma 3.
Any questions about that? Nicely done. Thank you, Cyrus. My only comment is right here, I would recommend doing what? Multiplying by x right away. Get rid of the denominators. You ultimately get to the exact same place, but there's no need to combine those fractions. Okay, try 18 and 19. Maybe I'll have some people come up. You want to discuss with your neighbor what's going on with that square there?
And you already, and you.
If this one goes. And if you make some meters, then you do. Shape your files.
Sure.
No, I think it's right, but I don't think it helps.
Yeah.
I think, yeah.
Oh, never.
Yeah. It's supposed to be more than 4 and 2 size.
Where's you find Y? It's just, you subtract. Then it's just log of x, right?
Mm-hmm.
And then. Then you get, what did you get?
Okay, yeah, I'm definitely get.
When I plug 10 at x. 10, 10, and then the base 10. And then 10. 4. And then you have to get 2/3 plus.
We're counting two people up. Silas, could you come up for number 19, whenever you're ready, not right now, and when you're ready. And for number 18, is there a volunteer for number 18? Am I? Too high.
I just don't know where to go.
Maybe it's being here. No, you can work wherever you want. Sorry, that's in the way.
It's the way that I do.
Yeah.
So. Why?
Yes, is that where you want to look at it? Perfect, thank you. Or do you want to continue?
I just don't know.
Yeah.
Or was there about 19?
Yeah.
Oh, if there's about 8.
I don't know.
Okay, are we good with number 18? We get that 2 comes down, it just becomes 2 like terms. You can combine them. You get x equals, I see you saw for y first, you got y equals 5, and you got x equals 10,000. Any questions about that? Nicely done, thank you. Okay, this one, we're dealing again, what's the thing called? Hyperbola, and this one is a circle, radius 2 root 2. So solve for x, so you can make everything in terms of y, or solve for y, so you can make everything in terms of x. You get something that looks like this. Josh, have an idea here?
I just set y squared equal to c, and then it's c minus 4 squared.
So c minus 8c plus 16, something like that. Okay.
And then to c minus 4.
Oh, so this is the quantity of c minus 4 squared.
And then c equals 4.
Is this true? Are we good?
Isn't it c squared minus 4 squared?
Oh, is this incorrect? So c is equal to 4?
Yeah, so y squared is equal to 4, so y is equal to plus or minus 2. And then when you put it back in, you get when y is plus 2, x equals plus 2, y equals -2, x equals to 5.
Nice, so we have y equals 2, y equals -2. Go back to the original. Or actually, I like going to here. X equals 4/2, so x equals 2, and x equals -2, so we get 2, 2, and -2, -2. If you're comfortable factoring this into y squared minus 4 quantity squared, don't feel the need to do the substitution. Substitution is a great way to simplify though. Shall we move on? Power through it. Funny, what are the shapes? What are the shapes? The first one is. What is it? Is there anything we're familiar with? First one?
Yeah.
Say it. What is it? Hyperbola? How do you know? Yeah. Two quadratics with the minus. What's the orientation? Horizontal or vertical?
Vertical is y.
It's y squared minus x squared, so it's definitely gonna be vertical. The other one? Is it also hyperbola? What's the orientation?
So
Show me. What's the orientation? Horizontal, vertical, which one? Are we good with it being horizontal? Be careful. It equals -6, doesn't it? Probably gonna have to divide by -6. It's gonna change things, isn't it? So I think we're dealing with two different vertical hyperbolas. Is it possible that this has any solutions? Sure, it's possible. Text or any. Do you have to use substitution here? Get it?
So people can.
First.
Yeah, just the first one. You're welcome to move on. You got it. Just completing my notes here. Okay, first one. I need some help from Piper.
Okay, so, I multiplied the second equation by 4. And then I canceled the x squared with negative x squared.
It's 9, so you get 4x squared minus 12y squared equals negative 24.
And
It's like a human. Okay,
cancel the 4x squareds.
what is this? Negative 15?
And I got y squared is equal to 5 and y is equal to root 5.
Plus or
Plus or
minus.
minus.
Are we good with that? Cool. And could you skip to the final answer
Okay, fine, that's
or answers? Or are you comfortable skipping to that or should I go through it?
negative 3, 5. Positive 3 root 5. Negative 3 negative root 5. And positive 3 negative root 5.
Like this?
Yeah.
Are you good with this? Yes, Eva?
Do you want us to write out each of the individual coordinates, or is it okay if we just do like plus or minus 3, plus or minus 3?
Was anyone else wondering that same question? Like, can we make it more efficient, right? Can we just do more with less? I'd be a little bit uncomfortable about putting plus and minus on both of them, but maybe 3 comma plus or minus root 5. So it's clear that those are 2 points. And then negative 3 comma plus or minus root 5. It's clear that's another 2 points. But to put plus minus and plus minus, I feel a little bit insecure with that. I know that wasn't what you were suggesting, but if any of you were thinking that, I just think that that would be good. Or if you want to do something like this, then do all 4. Something like that, just so I know that you know what's going on, which is fine. It's all about effective communication. Okay, moving on. I think I want to go to 22 and then just let you work through these on your own. 22, the danger here is being too diligent and maybe trying to clear the denominators. How would you do this without clearing the denominators? I'm going to ask you to check with your neighbor. What would you do here first?
Oh.
Oh, and I guess.
So what's the solution? How do we proceed? Josh, for 300.
We multiply the top equation by 5, and then we can set the equations equal to each other. Then at that point, it's just addition, subtraction.
Set them equal to each other. You multiply the top one by 5. But then we get back to what Kate was asking about earlier. Yes, we'd be able to make them equal to each other, but we'd have x and y in a single equation. I'm not sure that's helpful. I like the idea though. And it's not incorrect. It's just, I'm not sure it's helpful. But thank you. Yeah, Addison?
You should multiply the bottom 3. Or by negative 3, I guess, so that you can eliminate the x's in there.
And are you sticking with multiplying top one by 5?
Yes, yeah.
Do you see what she's saying there? Well, let's see what happens if I do this. 5 times 3 over x is 15 over x, yay, minus 10 over y equals something like 10. We have negative 15 over x plus 15 over y. Do you see how it's set up nicely? Just eliminate those over x's. I'll give you a chance to finish this up. Actually, I need to go through this with you because I don't want you to do too much work. So this is what 5 over y equals negative 20. Maybe I'll just make 1 over y equal to -4, is that right? Okay, which means that y is equal to -1/4. And to get the x. I'll let you finish it. It's not as complicated as I imagined. Okay. Check with your neighbor. Once you got it, or if you're stuck. So I just want to know the value of x. Layla, did you get it? Do we agree x equals -1/2? Okay, and you're putting these in ordered pairs? Thank you. Any questions? What method are we going to use for this? Elimination, not substitution. Let's eliminate together the what should we eliminate first, x's or y's? Yeah, let's eliminate the x's by multiplying the top one by 3, the next one by 5. So we have 15x minus 21y. It's 9, -15x. 15y equals 35. Did I do it right? That mess it up?
We're talking about these.
Oh, thank you. You are correct. So this is a 4, isn't it? Equals what?
11.
Okay, so y equals 11. That's a little nicer, isn't it? Okay. Instead of substitute that 11 back in, I'm going to do this a little bit differently. Just because in case you get a number that's difficult to plug in, like if we would have gotten some ugly fraction. Another way to proceed instead of substituting that first value in would be to start over and eliminate the other variable. Let's do that. Eliminate the other variable. In other words, if I want to eliminate the y's, I would multiply the first one by 5, the second one by 7, 25x minus 35y is 15, -21x plus 35y equals 49. For x equals 64. X equals 16. Now in that case, I think it would have been easier to plug in the 11, but I'm just showing you it's not difficult to go back, just eliminate the other variable. Ooh, it's getting hot. 4 and 25, is that it? Yeah, that's it. I give members to do number 24.
Get rid of this.
Yeah.
That isn't.
Not yet.
Wait,
Um,
yeah, because with this, like. It's like Make the rate. back. But the rate needs to be.
Did you get it?
Yeah.
Yeah, no, but I mean like. And the radius is just.
Yes.
It's like. Okay, like this is the absolute value. Or yeah. Yeah, but the hypotenuse for this like mean for the absolute value is. Two to get to one, believe it or not, like this is. Or this, oh, they're like a 45 rate.
So we're.
And if the rate is always gone, then it means that this value will be one, and since they're not the same. It doesn't intersect, doesn't. Or else these two values. So we need. So. The point is outside.
Why is this an easy problem?
It's basically.
Because it's the unit circle, isn't it? Is that the unit circle, really? Yeah, x squared plus y squared by equals 1 is by definition the unit circle, and that y equals absolute value of x is just those values at pi over 4 and 3 pi over 4, right? So I think it's negative root 2 over 2. Is that what it is? Root 2 over 2, comma root 2 over 2. Should we solve this algebraically?
No.
You can, but just be careful. Because I'm not sure how you would use absolute value of x. Like, how would you plug that in anywhere? So I think graphically speaking, it just makes the most sense here. To just use our prior knowledge. Something like this. Yes.
You know that it's, like you go to pi over 4.
Because the slope. It's up
Oh,
1
okay.
over 1. And it's definitely 45 degrees. If you want to do this algebraically, you could imagine you're dealing with y equals x and substitute that x in. Just make sure that you're not using any points that you would get here, or that negative x, y equals negative x, use that line here. Don't use this point either. So be mindful of restrictions for your solutions. But I think this is really nice just based on prior knowledge. 25. There's a trick. See if we can figure it out.
Oh.
Like that would make it true. There's like something that it like.
Is this an identity here?
Maybe.
It would be if these were the same. One's an X, one's a Y.
Oh, but they're nice for one. They're not really.
We know the trick. There's a trick. We're going to be using elimination to solve this. I don't recommend using substitution. I recommend using elimination, but how would you do that? Eva, you have an idea?
You can multiply by negative.
Multiply by negative.
And then, or
negative
not,
X.
well, actually, I'm not sure.
It's a neat idea, but I'm not sure that would give us anything to cancel. How do we get anything to cancel? How would we possibly use elimination? We have signs on the bottom, top, sign squares on the bottom.
On the top.
Simpler. I'm not going to multiply by anything.
Square, yeah.
Square both sides.
You know, so.
Have fun with the rest.
Oh,
I think you can find all solutions. Tap into your memory bank here. You just get 0 equals 0. Make sure you check in with your neighbor. You're doing this right.
Okay, so. Like two. Oh, wait. Oh, wait, right. I think it's.
0.0.
So. Oh.
Maybe on the test. That problem?
Something like it.
Maybe. You vote yes or no?
No,
He would be.
No,
asking if it
no
was-
trigonometry.
No trade?
Trig.
Is that a joke?
What?
Okay, so the top when you square it, you get sine squared of x plus 2
You sign.
sine x. Did you get that middle term there?
Yeah.
Plus
Cosine squared
cosine squared x. Oh, cosine squared y, thank you,
equals 1.
equals 1. And on the bottom, I'm setting myself up to
Wait, in the middle isn't.
Isn't it cosine y?
cosine y, thank you.
Yeah.
Oh, man, that's autopilot is real thing. Equals 1. So we have
2 sine x cosine y 0.
2 sine x cosine y equals 0. Now what? Anyone new? Someone who hasn't raised their hand yet? What do we do here? I'll give you a moment to talk it out.
Oh, I think. Yeah, like, let's start there. I just didn't want to-
What 3 letters should I be hearing? Z, P, E, right? Wouldn't that do it? Some here will say. Yeah, Josh.
So you can get rid of the 2 if you just divide by 2.
Okay.
And then using, CPP, you know, you can set sine x equals 0 or cos y equals 0. And or, I guess. And then I think that means that has to be at 0, 0, but I'm not.
Yeah, let's get all the solutions here. If sine of x equals 0, then x equals. Should I break out the unit circle?
2
Pi
plus pi n.
plus pi n. I use n. I'll take it. And here y is equal to over 2 plus pi n. Do you see that on the unit circle? So all those solutions? And of course, n is any integer. Right, only integers has to be able to make it to the other axis. Okay, so if x equals pi plus pi n, what do we do with that?
I feel like you just read it.
Can we just write that as an ordered pair?
I was just.
Let's take it one at a time. Let's go back to the equation, sine of x plus cosine of y equals 1. So if x equals pi, that means sine, oops. Sine of pi plus cosine of y equals 1. We know that sine of pi is 0, so cosine of y equals 1. That means y is equal to y is equal to, when is cosine equal to 1? Or does it work? It's pi over 2, is that right? No, it's not pi over 2, is it? Cosine of what equals 1? 2 pi? Just 2 pi? 2 pi n? Over here in the unit circle? The right side? How about pi plus pi n? So 2 pi, what if x is 2 pi? Would that be different? So it looks like we're getting a little bit of a mess, but let's see. X equals 2 pi, then I think sine of 2 pi is still 0. I think it works out to be the same, doesn't it? So y is equal to 2 pi n. So we have pi plus pi n, comma, 2 pi n. And then we would do the same thing for y equals pi over 2. Plus pi n. I'll let you finish that one. But I feel like I talked enough. I feel like you know enough to start the assignment. If you have questions, you're welcome to hang out for. Well, we're all hanging out. If you have questions, I'm happy to respond. Let me.
Don't want to find, but.
No, it's not true.